Okay, we're in section 7.3 now. So these are all associated with ratio, proportion, and variation. It's kind of actually, the variation part is more related to the next chapter, where one variable varies in direct proportion to the other variable. It's a linear equation, simple linear equation. Anyway, so let's start with number 3. So we have a group of problems here. Determine the ratio and write in lowest terms. So a ratio is just one number divided by another number. So in this case, these are pretty simple. You have $17 to $63. Notice the top and the bottom both have dollars, so those are what we would call units. You can have 17 cents to 63 cents. Since these are the same units, they're going to cancel out. So the answer is a fraction, a rational number. And then they say, is it in lowest terms? Well, 17 is a prime number, so the only way this thing's going to work out as far as simplifying is if you can divide 63 by 17, which you can't. So this is actually in the lowest. Oh, 68. It's like, what? Usually they give us one that you can reduce. I thought, boy, isn't that working? So I looked back at the problem. $68. Actually, you can divide 68. So the common factor is 17. So if you divide 17 by 17, you get 1. If you divide 68 by 17, you'll get 4. So this is the ratio of those two terms. So 5, similar kind of thing, 288 to 12 feet. Now that's one thing you got to be careful here. So the last one, the units were the same. So before you can do these ratios, you have to convert them to common units so that you can cancel that out, and you can end up with a unitless ratio. So we can either convert 288 inches to feet or 12 feet to so many inches. So it doesn't really matter which one you do. So I'm going to convert the denominator to inches. So there are 12 inches per foot. So if you have 12 feet, you're going to multiply by, you got to multiply 12 feet by 12 inches per foot, so that these units cancel out, and you'll end up with inches in the denominator. So ultimately, we end up with 288 inches divided by 12 times 12 is 144 inches. The inches cancel out now because it's the same units. And we have 288 divided by 144, which is 2. And we leave it as a ratio, 2 to 1, just instead of the number 2. So the answer is 2 to 1. And the last one in this section, same kind of deal, 75 minutes to 4 hours. So again, we have to convert to the same units. Again, we can convert hours to minutes or minutes to hours. I'm going to convert hours to minutes. We all know that there are 60 minutes per hour. So in the denominator, we multiply by 60 minutes per hour for 1 hour. So in the numerator, we'll get 75 minutes. In the denominator, we'll get 240 minutes. 6 times 4 is 24. 6 times 4 times 6 is 24. 4 times 60 is 240. Okay, so the minutes can cancel out. Now we got just numbers. And now we can simplify. So let's look for a common factor, which is 5. So if you divide 75 by 5, you get 15. And if you take 240, use my calculator, by 5, you get 48. Okay, you can't divide them by 5, but you can divide them both by 3, so we'll do that. 15 divided by 3 is 5. 48 divided by 3, I think, is 16. 16 and 5. So the ratio is 5 to 16, or 5 over 16. Okay, so that's how those problems work. What's this? Okay. 11. Explain the distinction between ratio and proportion. So let's go back, just look in the book, and let's see if we can look at them. So a proportion is a statement that says that two ratios are equal. So a proportion includes two ratios. A ratio is just the quotient of two quantities. So they're related. So a ratio is a quotient of two quantities. So these are ratios, whereas a proportion states that two ratios are equal. So, a ratio could be A over B. That's a ratio. 2 over 5. That's another ratio. Whereas the proportion would say that these two ratios are equal to each other. The ratio of A to B is the same as the ratio of 2 to 4. Next problem is 14. Okay, so we got a couple problems here. Decide whether each proportion is true or false. So this is number 14. So the proportion, which consists of two ratios that are equal to each other. So there are two ways of doing this. One way is to reduce them both to simplest terms, and then they should be the same. That's one way. Or you can do the cross product and see if the products are the same. So the easiest one is just to multiply them together. So you get 4 times 21 is equal to 7 times 12. 4 times 21 is 84. And 7 times 12 is 84. So since this is true, the proportion is true. Okay, we'll do one last one in this section, 17. So same kind of deal. We have 1/2 over 5 is equal to 1/10. So again, you could simplify these fractions, but the easiest thing to do is to cross multiply. So you'd have 1/2 times 10 is equal to 1 times 5. Well, 10 divided by 2 is 5, and 5 times 1 is 5. And you can use the same reasoning. Since this is true, the proportion is true.